Unit 1, Day 3. Today we're going to be discussing distance and midpoint. Before we discuss distance, we need to review the absolute value. Absolute value is the distance a number is from 0 on the number line. So ask yourself, is distance ever negative? The answer to that question should be no. Distance is never negative, ever. The absolute value sign looks like two bars, and then you input values inside. So let's recap. So for number 1, if I want to find the absolute value of 4, again, I'm asking myself, how far is 4 from 0 on the number line? So if I were to count, it's 1, 2, 3, 4 spaces from 0. So the absolute value of 4 is 4. Same idea, if I want to find the absolute value of negative 3, I ask myself, how far is negative 3 from 0? So count, 1, 2, 3 spaces. So the absolute value of negative 3 is positive 3. So what you should recognize is it doesn't matter what values enter the bar, the output is always positive. It doesn't matter what enters the bar, the output is always positive because the output represents distance. Now, to find the distance between two numbers on a number line, you will take the absolute value of the difference of the numbers. So the formula looks like so. Absolute value of the difference of the two values. So x sub 2 minus x sub 1. Now, it doesn't matter the order of your numbers for x that represent x. What does matter is that you carry out the absolute value operation properly. I do recommend using the number on the right first because it reduces stress later. So for 4a, we're going to find the distance between a and c. So first and foremost, draw your absolute value bar with your minus sign in between. Then insert the position x values. So if I look at the graph, C is the furthest on the right. So let's enter him first. So C is at location 2. Sorry. Get off my screen. All right. And then A is located at -5. Always put your negatives in parentheses. I want to see the formula written out, and I want to see the substitution into the formula into the correct places, please. After that, carry out your order of operations. So that's the absolute value of 2 minus -5, which ends up being 2 plus +5. So 2 plus 5 gives me 7. And now let's find the absolute value of 7, which should be 7, because 7 would be 7 spaces from 0 on the number line. Jump down to 6a. It says find the length of segment BC. Same question, just different wording. So again, draw my absolute value bars with my minus sign. And again, C is the furthest point on the right. So he's located at 2. B is on the left. He's at -2. Put him in parentheses. Now carry out your order of operations. So again, I have a double negative situation, which means it becomes plus positive. So 2 plus 2 is 4. And the absolute value of 4 is 4. So the length of segment BC is 4. Yes, you need to show your work, just as I have. Now let's talk about finding the midpoint between two numbers on a number line. The formula for midpoint, skeleton, there's a plus sign, a fraction bar, and a 2. And then at the top, you'll write x sub 1 and x sub 2. Again, the ordering doesn't matter. What matters is that you always use a plus sign when you're finding the midpoint and that fraction bar and 2. So for 4b, let's draw our formula skeleton plus fraction bar 2. And now let's insert the locations of our points. Order doesn't matter. If you want to stick with using the rightmost first, that's fine. So C is on the right. It's again at 2. A is on the left, again at -5. Now let's carry out the order of operations. So we're going to do 2 plus -5, which gives me a -3. And it is perfectly fine to leave your final answer as a fraction in lowest terms. And -3/2 is lowest terms. If you must, you can convert it to a decimal. Just make sure you convert it correctly. As a decimal, you would get -1.5. For 6b, it would like for us to find the midpoint of segment BC. Again, that's segment BC whenever you have that bar on top without arrows. And the methodology is the same. So let's set up our formula with the plus fraction bar 2. Again, C is the furthest on the right, located at +2. B is on the left at -2. Follow your order of operations. So you would have 2 plus -2 cancels each other out, leaving you with 0. And 0 divided by 2 is simply just 0. So the midpoint is 0. All right, I was trying to get my extended page down. Sorry it took so long. Number 7 says, if D is the midpoint of segment BE, find the location of point E. When you look at my graph, there is obviously not a point E on it. So our job is to figure out where point E would be located. They're telling us in advance that D is the midpoint between B and E. So the first step in this process is to find the distance between B and D. So to find the distance, we put BD without the bar because that represents length or measure is equal to, use the distance formula, so absolute value with the minus sign. And now use the rightmost one, which is D, comes first, that's 4, and B is at -2. So you would have the absolute value of 4 minus -2, which is the absolute value of 4 plus 2, or absolute value of 6, which means it is 6. So the distance between B and D is 6. Once you know the distance between B and D, you'll know the distance between D and E because D is the midpoint. And midpoint means that it's the point smack in the middle where it's equal distance on both sides. So starting I would now start at point D, and then I would add 6 to its value. So point D was at 4. If I add 6 to it, I would be located at 10. So point E is at spot 10 on the number line. Do this one on your own. Make sure you take a picture. Now we're going to talk about fractional distance. We don't always want the midpoint. Sometimes we want various other fractions. In this case, it's 1/6. So we're going to find x located on segment AF, and x will be located 1/6 of the distance between A and F. So you might want to highlight that segment. So A to F is right here. So X is somewhere between A and F, 1/6 of the way from A. Again, it's from A to F. So we're starting at A and moving towards the right to get to F. That's going to be very important later. To find the fractional distance, it requires 3 steps. The first step is find the total distance of the segment. So find the total distance between A and F. So AF, without the bar, means measurement. Distance formula has the absolute value sign and the minus sign. The point furthest on the right is F. It's at 5. A is at -7. So the total distance between A and F is the absolute value of 12, which is 12. Oh my goodness. There we go. The second step is to find the fractional distance. You find the fractional distance by taking the provided fraction in this situation, which is 1/6, and you're going to multiply it with the total distance, in this case 12. So to multiply fractions, again, you need to know how to do this without a calculator. Put this over 1 to make it a fraction, and then you multiply top with top, bottom with bottom. So that would give me a 12 over 6, which reduces to simply just 2. So my fractional distance is 2. And the final stage, we're going to add or subtract. So to determine if you're going to add or subtract, you got to look at where we're starting from. We're starting at A, and we're moving towards F. So we're moving in a positive direction. So in this particular example, we're going to add. When you're moving in a positive direction, you will add. And our starting point this time is A. So we're going to take A plus our fractional distance, which was 2. So A is located at -7, and then -7 plus 2 is going to give me a -5. So -5 marks the spot of point X. So if I were to graph it, this would be point X right there. 1/6 of the distance between A and F. Now we're going to talk about midpoint and fractional distance on the coordinate plane. The formula for the midpoint on a coordinate plane is very similar to the formula on the number line, except when you're dealing with a coordinate plane, you have both x and y, so you're just applying the formula to both variables. Again, you have the plus, the fraction bar, and the 2 for both x and y. And then you would have x sub 1 plus x sub 2. And the other one would be y sub 1 plus y sub 2. So make sure they're like variables before you enter them into the formula. On this example, it would like for us to find and plot the midpoint between A and B, given that A is located at -4, 5, and B is located at 2, -3. If you would like, you could graph point A and point B. So -4, 5 is right here. That's A. B is 2, -3, right there. So we're looking for the midpoint. The next thing I would do right away is label x versus y. So this is x1, this is x2, and then this is y1, this is y2. Write out your midpoint formula. So it looks like this. So we're finding the midpoint of AB. Don't forget plus fraction bar 2. All right, so x1 was -4, x2 was 2, y1 was 5, and y2 was -3. Now carry out your order of operations and remember to write it as an ordered pair. So -4 plus 2 is -2. 5 plus -3 is +2. Then reduce your fraction to lowest terms, would leave you with -1, comma 1 as your midpoint. So -1, 1 is right here. There's our midpoint. It asks us to plot. So I would like for you to do this one on your own. Don't forget to take a picture. So this next example is slightly different than the previous. Read it carefully. If Q is the midpoint of segment PR, if you look at my graph, there is no R. Where is a location for R? So again, Q represents the midpoint. We're not finding the midpoint. We already have it. So we're not going to apply the formula here unless you want to do some a little bit more complex mathematics, then go for it. Otherwise, we're going to apply the EME method. Endpoint, midpoint, endpoint. Our endpoints in this problem are P and R, and our midpoint is Q. Let's find the coordinates of what we have, and that will help us find the coordinates of what we need. So P is located at 2, 1, 2, 3, 4, 5, and Q is located at -2, 2. And now let's establish the patterns of our x's and our y's. So to get from +2 to -2, that is a decrease by 4. So if the pattern continues, I would continue to decrease by 4 on my x's. So -2 minus 4 would place me at -6. When I look on the other side, I go from 5 to 2. Again, that's a decrease, but this time by 3. So continue the pattern, decreasing by 3. 2 minus 3 is -1. So point R is at -6, -1. And last but not least, it wants us to find r on segment NM that is 1/4 of the distance from N to M. So now we're getting into fractional distance. If you recall on the number line, fractional distance had 3 steps. On a coordinate grid, it is double that because what you do to x, you must do to y. So the first thing is find the new x. So we're going to find the total distance of our x's and only focus on the x's. So again, it's the absolute value of x minus x. Order doesn't matter, but I recommend using the rightmost one first. So when I look at the ordered pairs for N and M is on the right, and its x value is 2. N is on the left, its x value is -3. So that would be the absolute value of 5, which is 5 for the distance on your x's. Now we got to find the fractional distance using the fraction provided, 1/4. We're going to multiply that with our total distance, 5. We're going to put 5 over 1 to multiply. And when we multiply straight across, so you would get 5 over 4, which is the same thing as 1.25. Either decide to keep it a fraction or change it to a decimal. That's fine either way. And the last stage on finding our new x is to add or subtract to the starting x. So we're moving from N to M. So we're moving towards the right. So since we're moving to the positive direction, we're going to add in this case. We're going to add. So our starting x value plus the 1.25 we had before. But I'm going to keep it a fraction. I think adding with fractions is a little easier for me sideways. So our starting x value is -3. And we're going to add, sorry, don't ignore that line under there. We're going to add 5/4. So again, we got to have a common denominator. So this becomes -12/4. And then -12 plus 5 is a -7/4. So that's our new x value. Keep that in mind. So now we have our new x. Again, we must repeat the 3 steps for y. So let's find the total distance of our y's. Our y on the right is at +3, and our y on the left is at -3. So that's the absolute value of 6, which is 6. Then we find our fractional distance using 1/4 again times, this time we're using 6 because we always multiply it by the total. So put it over 1, multiply straight across. You would get 6 over 4, which reduces to 3 over 2. And again, as a decimal, that's 1.5. Trying to get my extended page here. Sorry, folks. All right. And now we're going to add or subtract the fractional distance from our starting y value. So we're moving upwards also to get from N to M. So that's positive. So we're going to add. So we're taking n's y value plus our 3 over 2. N's y value is also negative 3. So we got to get a common denominator. So that becomes negative 6 over 2. Now negative 6 plus 3 is negative 3 over 2. So that's our new y. Last little tidbit and we're done. Write it as a complete ordered pair. So point R is at negative 7 fourths, comma, negative 3 halves. Ooh, parentheses. So this concludes the notes for this lesson.